Hi, my future self. So, what is a thread? Thread is basically the smallest executable part of a program, or should I say a process. That means if this is the RAM and this is our process, okay, so there can be multiple threads, okay, and these threads will be the smallest executable parts of these programs, okay. I'll get into that how these threads are executed. So one thread may do something like A equals 2 plus 3, and another thread may do B equals 6 minus 5. Though, so these threads should be independent of each other. Means if this thread does something like A minus a B equals A minus 5, so your compilation library will detect it before words. So it will not get even into the runtime. Okay. Your compilation library or your interpreter will detect it before words. Okay. So you cannot define these threads like one thread is dependent on another thread. Okay. You have to define A earlier. You have to define A equals, let's say, none before words, before even executing the thread in the main thread. Okay, so I'm not getting into this how to write code. Okay, so what is it? So that means if this is our RAM and this is the process, so threads are the smallest executable parts of this process. Okay, so how these threads are executed actually is, let's say there is a microprocessor core. I'm talking about microprocessor core, looks more like a TV antenna. Okay. A microprocessor is consists more usually microprocessors consist of multiple cores. So this is the single core. Okay. And I'm gonna make a bold statement. Microprocessors execute threads, not the processes. Microprocessors execute microprocessor cores. Okay, whenever I'll say microprocessor, I'll be referring to a core. So one microprocessor executes threads only, not the entire process. Okay, and but catch is you may not use threading. Okay, and let's say you may not use threading, and you can write the program in a simple way, like line by line, and this will be called a single threaded application, single threaded process. And what the smallest executable part of the complete process is the process itself. That's what we do. Okay, so then you can say this the microprocessor is running the process, but actually it's running this thread. Okay, so now if there are multiple threads, okay, so microprocessor at a time executes one thread only, or at most, at most two threads at a time. How? Microprocessor has some various mechanisms, say like hyper-threading, pipelining. So these things work like a microprocessor is made up of multiple parts, say the CU, control unit, and the ALU, yeah, I call it ALU, means arithmetic logic unit. So CU, ALU, and microprocessors try to optimize things, like if while CU is busy and the ALU is free, then it will keep the ALU busy by taking in another thread. Okay, so at most it can execute two threads at a time. Okay, and this completely depends on microprocessor and varies from microprocessor to microprocessor. Like it will not be the same for Intel and AMD. Okay, so this is completely dependent on the microprocessor. So, as a developer, As a developer, you should always think that a microprocessor at most can execute only one thread at a time. Okay, so this microprocessor is executing this thread. Okay, now let's say this thread is getting executed, and at one line of code, this is going to access the database. Okay, this is going to access the database. So there will be a network latency, there will be a delay, and there is not much work involved with the microprocessor. There is nothing for the microprocessor to do while the DB responses. Okay, so what it will do, it will go for executing another thread. Okay, another thread, and this going from one thread to another thread is called context switching. Context switching means it will save the stack of this thread and then it will make a jump. Okay, or maybe conditional jump. These are I mean, the lowest level of microprocessor instructions. Okay, yeah, conditional jump. Okay, so this microprocessor will jump to execute this thread. Okay, and which thread it will go for? Say there are three threads. You can see there are three threads. Okay, and this microprocessor, let's say this microprocessor was executing this thread. Okay, and it's now waiting for some kind of response. So you have got free time. So during the free time, will it execute this thread or this thread? This is completely dependent on the operating system. The operating system takes into consideration how much memory it has available or various things, and then it's the operating system schedules which thread will be executed by the microprocessor. And if you are not an extreme expert of operating systems, then you cannot predict which thread will be executed next. Okay, so there can be time that this microprocessor is going to execute this thread, and while this thread sleeps, it jumps into this thread. Okay, and there is no guarantee that which thread will be executed next. And usually in real life scenarios, there are multiple cores. Okay, there will be multiple cores in a single CPU. So multiple cores execute multiple threads of the same process. Okay, and if let's say this thread, and where the problem comes in is that in a multi-threaded process, okay, is that this thread, let's say, is accessing a Redis. Let's say Redis. Okay, Redis is nothing but Redis is just like a data. It's going to access a data. You think about it, it's like a data. There is written a equals to 2. Okay, there is written a equals to 2, and while it was going, it went to a equals to 2. Okay, it got a equal. The Redis gave a response, but there is a delay, and meanwhile, this microprocessor started change the pen. This microprocessor started executing this thread. Okay, so while this thread was going to Redis, this thread got a response of 2. And if when this thread went there and this thread, let's say, modified the 3 it to 3. Okay, and there can be multiple times that you thought that this thread should execute first, and after that this thread will execute, and then you will get a false value 2. Okay, so this is the problem. It has got too dirty. Okay, let me tell you one more time. Let's say there are multiple threads and the microprocessor. Okay, and you don't know which thread will be executed. You can't predict the order in which these threads will be executed. So this microprocessor can execute any of these threads, and which is completely dependent on the operating system. And usually we developers don't put much brain in operating system. I mean, I don't put much brain in operating system. Okay. So this microprocessor is going to execute one thread at a time. Okay, but there can be multiple microprocessors and they will execute threads concurrently, and that's the best part of threading. Threading can actually achieve concurrency by leveraging two microprocessors executing two threads of the same process. Okay, so for CPU bound tasks, CPU heavy tasks, it will be a huge performance improvement to use multi-threading. Okay, you can, by using multi-threading, you are leveraging two microprocessors cores. That means you are cutting the time to half. If you can, you know how to use the multi-threading very well. Okay, but there is one more way. Okay, multi-threading, I told you about multi-threading, but there is one more way, that is called single-threaded asynchronous process. What does that mean? It means that there will be only one thread in this process. Okay, and if this there is it's what's that, running this code line by line by line. Okay, and let's say it hits something that doesn't need much attention of the CPU. So let's say it's some kind of DB access or disk IO or whatever it is. Okay, so what it does, that this is a coroutine. This is called a coroutine, and this microprocessor, this thread moves on. Okay, keeping it on an event loop. There is something called the event loop. Event loop. I know my handwriting is very bad. Okay, so this goes into the event loop and it starts executing the remaining code. Okay, and when the response is ready, okay, it gets back to the response, processes it, and continues doing this. So this is highly optimized. Why? Because while switching, I told you about context switching. While switching from one thread to another thread, the microprocessor needs to write a slightly more data in the RAM. Okay, in this RAM. Okay, while saving the stack, I told you that the microprocessor saves stack. So while jumping from this thread to this thread, the microprocessor writes the stack. Okay, and there will be little more data compared to this event loop and this single thread application. And more data means it will be more. It will take more time to write in this RAM. Okay, so the context switching is a little costlier than this event loop, what's called coroutine registration, you can say coroutine registration. Okay, so that's why nowadays modern frameworks like Node.js are using this single-threaded asynchronous architecture. Okay, but there are also limitations. Single-threaded cannot truly achieve concurrency. It may have seemed, because there is event looping. The event loop will be very fast, and it may seem like it's achieving concurrency, but it's not actual concurrency. Actual concurrency is multi-threading. Okay, and if I get into Python, okay, Python has even more complex mechanism, say the GIL. What is GIL? GIL is, let me write it, Global Interpreter Lock. Okay. GIL is Global Interpreter Lock. So what does it do? In Python, okay, in Python you can write code with multiple threads. Right? You can write code with multiple threads. Okay, there can be multiple threads in Python code. Okay, in the Python process. Python process means basically the Python interpreter. I'll get into process. What is a process? Okay, but there you can write multiple threads in this Python code, but kill ensures that only one thread of this process is executed at a time. So even though there are two microprocessors, okay, only one thread will be executed of this process. Okay, and this other microprocessor will not touch this process. Okay, now what it will do, it's completely dependent on the operating system. If it has nothing to do, it will sleep. Okay, and if it has another process, it will go for that process, but it will never execute another thread on this process. This is ensured by this global interpreter lock in Python GIL. So for this GIL, people say that Python is very inefficient, but it's actually not. Okay, Python is not that much inefficient that you think. Yeah, I know it's slower than C, C++, but still it's okay. It's okay, man. It's fast enough. Okay, and if you only think about fast, there are more things like uh, code quality. Code quality, that's the thing. Okay, and in Python it's extremely well. You can structure your code extremely well. The main code maintainability, awesome. Okay, so people nowadays are moving towards Python. Okay, okay, but of course you have to admit that C is the fastest compilation language, fastest programming language, let's say. No, assembly might be. Okay, well, I'm not gonna get into that. Okay, so the RAM and this process, sorry, this multiple threads. Okay, and I told you about single threaded asynchronous framework and Python skill. So let me give you another example how this threading works. So let's take the example of gRPC, Google Remote Procedure Call. Okay, or Golden Retriever Pancakes. That's what actually written in the Google's official documentation. Okay, that's why I'm saying. Okay, whatever it is. gRPC. In gRPC, if you are running a gRPC server, there are two kinds of gRPC server. Okay, single-threaded and I mean synchronous and asynchronous. Means synchronous means this. I'm talking about the synchronous one. Okay, so there is one thread and this thread spawns multiple threads, okay, that you define. Okay, so let's say there is this main thread. Okay, there is this what is happening, the main thread. There is a main thread and there are multiple threads that this main thread had spawned. Okay, so whenever a new, and there is a microprocessor, okay, and you know, due to the global interpreter lock, only one thread at a time will be executed. So the purpose of this main thread is to keep the program alive. Okay, so that means it creates a main loop. It creates basically a loop. Okay, and this keeps the program alive. This keeps the server running, and whenever a request comes in, it allocates this request to one of these threads. Okay, and this thread starts executing this process, this preparing the response. Okay, and whenever this thread hits some kind of waiting, like DB access or Redis access, whatever it is, if there is another if there is another request waiting in this, what is it, thread, it goes for the another thread, and if there are multiple requests waiting on multiple threads, then there is no guarantee which thread will be executed first, but one thread will be executed at a time. Okay, and if it has nothing to do, then it will go to get back to the main thread and will just keep the program alive. Okay, so this is how the multi-threading works. I hope this is clear enough. Now oh yeah, one more thing about multi-threading is there. What is it? Thread. Okay, one more thing about multi-threading is that in a process, threads execute the same, its threads share the same memory space. That means I have tried this too many times, microprocessor kind of thing, that old TV. So this thread share the same memory space. Means if there is a variable, say a equals to 2, and this thread gets access this variable and does something like a plus plus. So now this variable is 3. And if after executing this thread goes for a, it will get the response of 3. It will see that 3 is written in this space. Because that's what threads share the same memory space. But that's not the thing for processes. Okay, so now let's get into the processes. processes are basically there to separate the memory access, nothing else. Okay, to separate the memory access to the operating system itself is a process, and the operating system use see other applications just like processes in order to keep them isolated. So the thing is, there is a microprocessor and there is a process. There are two threads and there are two threads. Okay, so if this is a process and this is a process, like you say your Python interpreter, when you type Python in your terminal and there is an interpreter and there is a console opens up and you execute code line by line, it's basically a process. Okay, and whenever you are writing a python.py file and executing it, it's basically creating an interpreter process. It's creating an interpreter process and executing the code line by line in this process. Okay, so if there are multiple threads, okay, so this thread this thread cannot access some data, some variable written in this, sorry, I'm talking about, so this process cannot access some data written in this thread, in this process. Okay, let me clarify again. This is the RAM and there are two processes. Okay, so this process cannot have access to the memory space of this process. This is not possible. Okay, so you may see in lang programming languages that you are actually passing some variable, let's say a equals to, and you're passing it to this process, and this process is getting a equals to 2. But under the hood, what happens is that you write here a equals to 2, and a copy of this variable is created right here with the same name, because two processes can have the same variable, can same variables. Okay, e equals to 2. But the thing is, if you do here, like if after setting the variable, you do something after sharing the variable, after passing the variable to this thread, you do something like a plus plus and you try to get a. Here you will not get 3, here you will get 2. Okay, because they are the copies of this same variable. These are the copies of the same variable. Okay, they are not actually the same variable. Okay, but this is not the thing for threads. And there are definitely ways to share some object on the memory. That's by creating some shared object. Means you create a equals to 2 here, and if this is a process and this is a process, then they both can have access to this. Okay, so if at the time this process does something a plus plus, and after that this process goes for accessing, then it will get 3. Okay, so I think this is how multiprocessing works, and in Python you have got something like got a module called my multiprocess module. So what it does is that this single process spawns multiple processes. Okay, multiple Python interpreters. Okay, and they do same thing, and the global interpreter lock is for threads, not for processes. Okay, so two Python processes can be executed at the same time. These are processes. Okay, and these are threads. See the difference. Okay, these are processes and these are threads. Okay, so microprocessor, one microprocessor can at most execute only one thread of a process. Okay, but usually our CPUs have multiple cores. Okay, and two Python processes can be executed concurrently. Okay, so in Python, how you achieve true concurrency is by doing multiprocessing. Okay, multiprocessing. So there are multiple cores. Okay, and let's say there are multiple threads. Okay, so this, while this core is executing this thread, this core may execute this thread. Definitely, if you are running it in a containerized environment, then the OS doesn't have much work to do. Mostly, one, if there are two processes, I mean, you have spawned two processes using the multiprocess module of Python. There are two processes and there are two microprocessor cores available. Then if this microprocessor is executing this process, one thread of this process, this cannot go for this thread, so the operating system will schedule one thread on this process. Okay, this is mostly the case. And let me tell you, in Docker, the Docker containers are nothing but processes. Okay, also the Kubernetes pods, are also processes. Means not the Kubernetes pods, it's actually the container running inside the pod are the processes. Okay, so even if say Kubernetes pod is running two containers. Oh, looks nice. Okay. Let's say two containers. One pod is running two containers. So this will the microprocessor will see that these containers are nothing but these processes. Okay, and they will do accordingly whatever is needed. Okay, so I think that's enough today for clearing how microprocessor works. Last time, truly last time I'm drawing this. The microprocessor and threads work. To, uh, enough, yeah, enough. That's all. Okay. I hope it will clear my doubts in the future.